The Sentinel role is responsible for monitoring, modifying, or terminating one or more non-deterministic algorithms/rules. This role essentially involves figuring out when one or more of these rules act abnormally and then taking action to keep them stable. So even if a non-deterministic rule can be a lifesaver to identify potentially bad actions by entities that haven't been thought of before, it isn't always perfect. And if it starts acting strange and starts impacting the network, steps have to be taken to keep things stable. Alongside the baseline criteria, one additional criteria appropriate for this role could be that the Sentinel must have been mostly constantly online and reactive for a determined time frame and have fairly quick node hardware. Another one could be to have an average global score above a determined threshold and to never have been blacklisted. Moreover, alongside the baseline restrictions, some appropriate restrictions for the Sentinel role could include the number of polls the Sentinel can start over a determined period of time, according to its Sentinel level, the number of polls started by the Sentinel and voted in by the Sentinel over time, and the like. In order to generate a valid poll, the Sentinel needs to gather some pre-poll information. This pre-poll information generally includes things like the Peterson of the Sentinel and an action the Sentinel proposes to take for the non-deterministic algorithm. In order to determine if and what action to take for a given non-deterministic algorithm, the Sentinel will analyze and compare its behavior to a set of weighted conditions and parameters. For example, is it punishing entities for things that are already covered by other deterministic rules? After manual diagnosis, is it punishing entities in a way that wasn't intended? Did another non-deterministic algorithm predict with high certainty that it is acting erroneously? If it's behaving strangely, how severely is its strange behavior affecting the system? While the analyzing of the behavior is usually done automatically as a part of the system, manual diagnoses are also possible to implement, as hinted earlier. If the Sentinel judges it is acting strangely, it will propose an action to take to eventually fix it, for example, to suspend or update it. If the algorithm was previously already suspended by another Sentinel, and the Sentinel judges it is now acting normally, the Sentinel may propose to activate it back. Therefore, in most implementations, there are essentially three default possible actions that can be proposed by a Sentinel: suspend, activate, and update. The suspend action suspends the non-deterministic algorithm if it is currently active, making it inactive. Indeed, sometimes an algorithm needs to be stopped so that specialized Sentinel entities can figure out what is wrong with it and fix it, or so that a completely new non-deterministic algorithm can be put into place using the rule-adding mechanism described in a previous video. The activate action activates the non-deterministic algorithm if it is currently inactive. This could be done if a Sentinel judges that a previously suspended algorithm is now behaving normally and can be trusted again, for example, after an update action. The update action allows updating a non-deterministic algorithm by changing its parameters, fixing bugs, and the like. This is similar to the rule-modifying mechanism mentioned in a previous video, but reserved only for specialized Sentinels and concerning non-deterministic rules. The rationale behind this is to limit entities that are not specialized in the technical domain of probabilistic algorithms used by non-deterministic rules from having a biased impact on related decisions in the system, and thus to leave such decisions to specialized entities. Once the pre-poll information has been gathered, the Sentinel creates a poll transaction with it. This transaction also requires one or more partner Petersons to be associated with it, using the partner selection process described in a previous video. Finally, the Sentinel broadcasts the transaction to the network. In some implementations, if two or more Sentinels try to create a poll in a small period of time, then one of the two polls will be discarded. As such, only one Sentinel poll at a time could be within a given block. Several methods can be used to determine which Sentinel poll will be discarded, such as the Sentinel level and the frequency of poll creation per Sentinel. Upon validating the poll creation transaction, other Sentinels in the network will vote whether or not they are in favor of performing the action for our non-deterministic algorithm, by analyzing the pre-poll information specified in the poll creation transaction. Once enough votes have been cast, the action proposed for the non-deterministic algorithm will either be performed if the poll is accepted, or the Sentinel who created the poll will be penalized if refused. A poll can also terminate before enough votes have been cast if a determined number of blocks have been generated since the poll's creation. The penalizing of the Sentinel can vary greatly. For example, it could be proportional to its Sentinel level. Moreover, some implementations will also choose to penalize Sentinels who voted against the final result of the poll. A system like the entity reporting system mentioned in a previous video can also be used to allow entities to report malicious polls even after being finalized, and have the system take corrective actions accordingly. For example, if a poll result is positive but it is later shown and proved that the poll was malicious, the entities who voted in favor of the poll could suffer punishments, while non-malicious entities who have been punished in the past could be compensated. BB Inventions, high-tech research for curious minds.